Welcome back, everybody, to the second part of section 6.5. We're going to be finishing up the operations on radical expressions. The first thing I want to talk about is that a lot of combinations with radical expressions, whether you're multiplying or adding or dividing, require that we have like indices. This is just the radical expression equivalent of combining like terms. We can't combine when we're doing addition. In the same way, we can't combine in doing multiplication. I should be very careful with my words here, because we can actually do this multiplication. Doing this results in a new kind of radical. So when we're doing multiplication, we're going to look for like indices. In the case of addition and subtraction, we actually want to go one level deeper and talk about not just like indices, but totally like radical expressions. And radical expressions are only alike if they have the same indices and the same radicand. This subtraction problem contains like radical expressions. We have both the same index 4 as well as the same radicand 2x. Only in the case that we have like radical expressions can we do addition and subtraction. And only in the case that we have like indices can we do multiplication easily. But plenty more about multiplication of radical expressions in the future. The first operation I want to have a look at is multiplying radicals. In this case, all we're doing is applying the product property that we learned in the last video to some more complex expressions. Let's look at a simple example and then a more complex one. If we want to do this multiplication problem, it's really just a matter of applying the product property. We can multiply the pieces outside the radicals, and we can multiply the pieces inside the radicals, but only if we have like indices, which we have in this case. So, in doing the multiplication on the outside, we end up with 6. In doing the multiplication on the inside, well, let's see, the 4 times 6, that gives us a 24 on the inside. And the x times x squared, well, that's x cubed. So now we've completed this multiplication problem, but we still need to simplify it if we can. And I think there are some big hints that tell us that we can, in fact, simplify this problem. Our index is 3, and we have an x cubed sitting inside. So we know already that we're going to be able to take this x cubed and pull the x outside here, and that 3 is going to get canceled. Let's take that intermediate step here. Now we have only to ask ourselves, is there another perfect cube hiding inside the radical? Well, let's think of our perfect cubes. 1 is a perfect cube, 8 is a perfect cube, 27 is a perfect cube. Well, we've already stopped by 24, but 8 is a factor of 24, so we can actually rewrite this expression with 8 times 3 inside the radical. Now we have a perfect cube that we can pull out, and the cube root of 8 is 2, so it's 2 that goes outside. That leaves us with 12x on the outside of the radical, and 3 all alone on the inside. So here's the simplified version of that product, and it really just relies on us using the product property. Next, let's have a look at addition and subtraction involving radicals. Now, as I mentioned before, this is going to require like radical expressions. So we can't add or subtract unless we have the same index and the same radicand. And this should be a familiar concept to us. We can't add things that aren't like to begin with. The challenge with problems like this is that sometimes we can actually simplify one or the other of the radicals and create like radical expressions. For instance, let's take a look at this problem. The square root of 98 minus 2 times the square root of 32. The place to begin here is simplifying each of the radical expressions and seeing if we can come out with like radical expressions. Well, 98 is 49 times 2. 49 is, of course, 7 squared, so that means we can actually pull a 7 out of this radical. This becomes 7 times the square root of 2. It's as simple as we can make that one. Let's look at the other expression. Well, 32 is 16 times 2. And 16 is 4 squared, so we can actually pull a 4 outside that radical as well. That'll give us 8 on the outside, with 2 on the inside. Now we actually have like radical expressions. Both of them have the same index, 2 in this case, and both of them have the same radicand, also 2 in this case. So when we're doing the square root of 98 minus 2 times the square root of 32, what we're actually doing is 7 times the square root of 2 minus 8 times the square root of 2. And this actually turns out to be a very simple subtraction problem, because all we're doing is saying we have 7 square roots of 2, and we want to take away 8 from that. That leaves us with -1 square roots of 2. Let's do one more quick example. Well, in this problem, let's once again simplify each side separately. The square root of 8, well, there's a 4 in there, 4 times 2, and that 4 is a perfect square, so we can pull that out front. How about 50? Well, we can break that down as well. That's just 25 times 2. 25 is a perfect square as well. It's a square of 5, so we can pull that 5 out in front. All right, now all we have to do is actually do this addition. We have 8 square roots of 2. We're going to add 15 square roots of 2 to that. So really, 8 plus 15 is the hardest math we have to do in this case. We have 23 square roots of 2. So much for adding and subtracting radicals. The last thing I want to take a look at is combining the two things we just did, multiplying radicals as well as adding and subtracting them. In this case, we're going to end up with products of radicals that are added or subtracted. Let me show you what I mean. Hopefully this setup looks somewhat familiar. These are really just binomials, and when we multiply them, we can FOIL them out, distribute them just like we do any other binomials. Let's FOIL to make this as simple as possible. We're definitely going to use the product property here. So our first term, multiplying those together, gives us 12 times the square root of 3 times 2. That simplifies pretty easily. Our outer terms, well, that's -6 times 4. That's -24 times the square root of 3. Our inner terms, 5 square roots of 2 and 3 square roots of 2. Well, we can do that direct multiplication. On the outside, we have 5 times 3, and on the inside, 2 times 2, or 4. We might as well simplify that up front. The square root of 4 is just 2. Looking at the last terms, 5 square root of 2 and -6, we just need to multiply those numbers outside the radical. These are the 4 terms we end up with. Let's put them all together into a single sum. So these are the 4 terms when we put them into a single sum. The question now is, can we simplify anything here? Well, as we know with adding and subtracting radicals, we need to have like radical expressions. So of all of the radical expressions we have here, are there any that are like? No. So really this is as simple as we can make this sum. But all that's involved is doing a little bit of foiling. We'll come back and take a look at several examples having to do with this kind of work in the next video.